All right, this is section 2.6, rational functions and asymptotes. First of all, the definition of a rational function, it is when we have p of x over q of x, where p of x and q of x are polynomials, and q of x is not 0 because we can't divide by 0. We're also going to assume that p of x and q of x have no common factors, but we're also going to talk about what happens if they do. We're going to start off with asymptotes. Remember that an asymptote is that invisible line that we approach but never quite touch. So the line x equals a is a vertical asymptote of the graph of f if f of x approaches infinity or negative infinity as our x value approaches that a from either the left or the right. So a vertical asymptote, invisible line, that the graph gets very close to, very close, but will never touch or cross. So what that looks like in a picture is, let's say this is my vertical asymptote. My graph can get really, really, really close to it, but it's just going to shoot off to infinity. Or maybe it's coming down from down there, really, really close to it, but never quite touches it. And then we also have a horizontal asymptote. If f of x approaches this number b, as x approaches positive or negative infinity. Horizontal asymptotes are a little different because you can cross these in the middle. But the ends get very close of the function. Without crossing. So you can cross a horizontal asymptote in the middle of the graph, but the ends are the ones that are going to get really, really close. So if this is my horizontal asymptote, what I'm saying is my graph can do whatever I want in the middle, but on the end, the far right, it approaches that line, or let's do this one, the far left. Really great sketch there, I know, but it gets really close to that horizontal line on the far left or far right, or both. Some pictures of asymptotes for us. We've got a horizontal asymptote and a vertical asymptote here. This one just has a horizontal asymptote. This one's got a horizontal and a vertical. Notice that the little guy is going to slide down forever, and he will be stuck down there. So for asymptotes of a rational function, our rational function is given by p of x over q of x. It is just some polynomial over some other polynomial. You'll notice I have it written, I use a's on the numerator and b's on the denominator, n's for the power in the numerator, m's for the power in the denominator, because these are going to be different coefficients and different powers possibly. The graph of f has vertical asymptotes at the zeros of q of x. That means vertical asymptotes when the denominator equals 0. Denominator equals 0. The graph of f has at most one horizontal asymptote, and there are 3 possible rules. If n is less than m, so this is numerator is less than denominator. I'm talking degree here. Degree. The x-axis is the asymptote, which means it's y equals 0. If n equals m, so the numerator and denominator have the same degree, the line y equals a over n, or a sub n over b sub m, is the asymptote. Those are the leading coefficients. As a fraction, simplify. And if n is greater than m, which means the numerator has a bigger degree than the denominator, there is no horizontal asymptote. So we're going to start with horizontal asymptotes. We'll get into the vertical ones in a moment. For horizontal asymptotes, we have tricks. I look at the degree of the numerator. The degree of the numerator is 1. Then I look at the degree of the denominator. The degree of the denominator is 2. Well, the degree of the denominator is bigger, which means my horizontal asymptote is y equals 0. For g of x, I'm going to look at the degree of my numerator, which is 2, and the degree of my denominator, which is also 2. They have the same degree, which means my horizontal asymptote is y equals, take the leading coefficient from the numerator, which is 2, and the leading coefficient from the denominator, which is 3. My horizontal asymptote is 2/3. And finally, for h of x, the degree of my numerator is 3. The degree of my denominator is 2. The degree of the numerator is bigger, which means there is no horizontal asymptote. All right, now we're going to find vertical and horizontal asymptotes. Let's start with vertical. To find vertical asymptotes, we're going to factor the entire problem. You always need to factor the numerator also. We get x plus 2 times x minus 1 for the numerator, and x minus 3 times x plus 2 for the denominator. Well, what makes the denominator 0? X equals 3, and x equals negative 2. But please notice that negative 2 also makes the numerator 0, which means it's actually not a vertical asymptote. We're going to talk about that in just a second. So our only vertical asymptote is x equals 3. For our horizontal asymptote, we're not going to look at the factored version. We're going to look at the original. The degree of the numerator is 2. The degree of the denominator is 2. So I just take my leading coefficients, which is a 1 and a 1. So y equals 1 over 1, which is just 1. For my second problem here, we are going to factor the numerator and the denominator as much as I can to find my vertical asymptotes. Well, the numerator can't really be factored. The denominator is x plus 1 times x minus 1. Notice none of those factors cancel. So my vertical asymptotes, there are 2 of them. X equals negative 1 and x equals positive 1. For my horizontal asymptote, notice that the degree of the numerator and denominator is the same. So I take those leading coefficients, 2 over 1. My horizontal asymptote is just y equals 2. So what if p of x and q of x have a common factor? If the numerator and denominator have a common factor, then the graph of the function has a hole at that 0. So that means this last problem here, where I crossed off the x equals negative 2, that's on asymptote. That was just a hole in the graph. Basically, it means that my graph is going, oh, we jump one little point and then go again. So let's take a look and find some asymptotes, holes, and whatnot. Start off with factoring the entire problem. My numerator factors into x plus 3 times x minus 3. My denominator factors into x minus 3 times x plus 1. Well, I see that x minus 3 cancels, which means my graph has a hole at x equals positive 3. Now, we're mostly just talking about asymptotes, but I need you to realize that is just a hole in the graph. So vertical asymptotes, the things that are left that make the denominator 0, is just x equals negative 1. For my horizontal asymptote, my numerator and denominator have the same degree. So I just take my leading coefficients, which is a 1 and a 1, and I get y equals 1 over 1, which is just 1. And one last problem for us here. We're going to start by factoring the whole thing. My numerator factors into x plus 1 times x plus 1. My denominator is x plus 1 times x minus 1. One of these x plus 1's cancels, which means we have a hole in this graph at x equals negative 1, because we're talking about that 0 there. We have a vertical asymptote when x minus 1 equals 0, so at x equals positive 1. Horizontal asymptote, our degrees are the same, so 1 over 1, which is y equals 1.